Can a computer be aware like a human being? Can artificial intelligence ever match the human mind in every aspect? This is a very interesting question and very fascinating question on which the various researchers are working day in and day out to get the answer to this question. But before getting into the issues of building intelligent computer, it is worth mentioning the related work in the field of biology and biological engineering from last few decades. In particular, we can think that cloning technology as a different way of creating artificial human life in a laboratory. And in past few decades, scientists have worked hard and they are being successful in developing some kinds of clones of plants and some animals. So the attempts of clone of human is still ongoing. And with the advent of science and technology, in next few decades, we are thinking that yes, it could be possible that we can clone human body also. But again, if we will clone it, then definitely in some ways it is not artificial intelligence, since we will be creating actual human beings. But still, there is a way of creating consciousness in the laboratory because it will be different from that conventional approach. So these are the various thoughts. And when we talk about artificial intelligence, we definitely refers to that regarding computers and robots. But it is been very difficult to agree that what artificial intelligence would mean, because various researchers in AI are having various different concepts. Like they are having major schools of thoughts. One school of thought, we start with things that system that act like humans. We are supposed to develop a system that act like human, and it is very closest to the Turing test proposed by famous computer scientist Alan Turing in 1950s. And it was designed for the operational definition of intelligence. By operational definition, we mean that proposing a long, likely controversial list of conditions needed for intelligence, and for that Turing suggested a simple test. And if that test works, then a human being possesses some questions to the computer and they get some written responses back. If the computer, like on the basis of human questions being not able to answer it correctly, then we can say that no, it is not intelligent. But if it works like that, we can say yes, it is intelligent. So this is the only way. And in order to pass the Turing test, a computer would need to have a number of capabilities, such as the ability to communicate successfully in English or other natural languages, to effectively store what is knows and reads, and to perform reasoning, to use the information it is given to answer questions and draw new conclusions, and to learn from controversial patterns over time. Researchers have not spent much time trying to build systems that actually pass the Turing test, but trying to solve these underlying problems has been a major part of research efforts in artificial intelligence. So the major school firstly we discussed was a system that act like humans, but now it comes a system that thinks like humans. And this school is sometimes called the cognitive modeling approach and defines AI as automating activities associated with human thinking, such as decision making, general problem solving, learning, and so on. A major difficulty with this approach is that in order to be able to say that a computer is thinking like a human, we need to first figure out how human thinks, and this is very interesting, which in itself is a very hard and still unsolved problem. This requires conducting psychological experiment and trying to develop a biological and cognitive theory of how the mind works. Once the theory is good enough, we can use the theory to design a computer program that matches human behavior. One example of system that was trying to do this was the general problem solver that Alan Newell and Howard Simon designed in 1961. They were more interested in having the computer go through the same reasoning process as human subjects, solving the problem related to some kind of reasoning and all. In the early age of AI, people were often confused about this distinction. They would argue that because a program solved a problem directly or correctly, the program was a good model of human performance. The issue is that, of course, humans often don't solve problems correctly, and a program that really mimics human behavior should make the same mistake. These days, people would separate the two claims, and the field of cognitive science is more concerned with building models of human thought and behavior, which researchers in artificial intelligence now focus more on getting programmed to solve difficult problems correctly. So if we see, this highlights a split between older researchers in AI, like during 1950s to 70s, and some modern researchers like 1970s to present, and brings us to the next two schools. Roughly, the two definitions that will measure success in terms of how close the program is to human behavior, while the two below will measure success against an ideal concept of intelligence, which is usually called rationality. Basically, a system is a rational if it does the right thing based on the information it has access at that time. And then the third major school of thought, which comes a system that think rationally, the attempt to codify thinking the right way. This is very interesting. The attempt to codify thinking the right way goes back to the Greek philosopher Aristotle's work on formal logic. He suggested some patterns or arguments that always yielded the correct conclusion when given correct premises. For example, Socrates is a man, all men are mortal, therefore Socrates is mortal. Originally, these laws of thought were intended to be the ones govern the operations of mind. Even by 1965, there were programs that could, in principle, solve unsolvable programs that could be written in logical notations. Through 1970s, there was a strong movement within AI called the logistics school that tried to improve on such programs to try to create intelligent systems. There were two problems with this approach. First, it is hard to take informal knowledge and state it in formal logical notions. Very interesting. It is hard to take informal knowledge and to form its logical notion, particularly when there is some uncertainty about the information. Second, these programs were often very slow, and so solving even small programs proved impractical with these methods. This brings us the most common modern view. And then the fourth middle school is related to systems that act rationally. This school defines artificial intelligence to be concerned with the design and construction of rational agents, which are computer systems that act to achieve the best outcome, or when there is an uncertainty involved, the best expected outcome agents are assumed to have additional features that separates them from like normal programs, such as operation by themselves, perceiving and reacting to their environment, and adapting to change. One major advantage to this approach is that it is much easier to develop scientifically. The standard of rationality is being clearly defined and very general, which we still do not have a good understanding of human thought and behavior. Moreover, it is more useful to build systems that can do the right thing in a given situation and solve problems much better than human mind. And even human might solve that problem in a different way, but like we can design machines that can solve the problem with more accuracy. So because the definition is so general, however, it is also included many kinds of systems that most people do not think of as real AI. For example, a spam filter is considered as a rational agent because it adapts over time depending on email you receive. Its goal is to behave rationally by correctly classifying every mail as a spam or not. Similarly, some researchers are working on cars that can drive themselves, or helicopters that can fly themselves. A robotic car is certainly not a replacement for the human mind, but it does not need to be able to learn, adapt, and exert control intelligence in the context of driving. This kind of work is considered to be a part of modern AI. So, like if we see, then the first question has been approached in different ways and even redefined over the years. Human beings are themselves agents of a certain kind that do certain things well. Like if we see, then commencement of reasoning, communicating, and other things poorly, like carrying out complex calculations quickly and all. Computers are different kind of agents that in general appears to have complementary capabilities, that they can be very logical and calculative, and they can do the calculations very quickly. And like other things which we can see is that sometimes they use good common sense of reasoning. And like if we see, then the overall thing, if we consider, then definitely there are different kinds of schools of thoughts, like strong AI, weak AI, and on the basis of that, when we try to redefine our concepts, like whether it is possible or whether it is not. So again, we find that the question is still on, and we are going deeper and deeper. We are thinking a lot, we are working into this concept that whether we can make computers think, whether we can make computer aware, and we must think on it because the answer will come out naturally.